Hello YouTube. So a while ago I made some videos about my custom computer architecture, and today we are going to be making another update on that project. So for today we're going to be looking at another paper that I wrote, and this is going to be about the RAM-ROM programmer and the architecture for the assembler for this computer. So at the basic level of how am I going to program this thing, we have four components. There is a PC, an Arduino, and then inside of the computer is the RAM and the ROM, and the CPU. So basically what I want to do is I want to write a program to run on the PC, which is basically a text editor development environment. And what this will allow me to do is to write my assembly instructions that will be running on the computer. So, and that is going to be just the words for each instruction, as well as the operands, and these are usually going to be an address, though they may sometimes be a value. And then this is the instruction. So what I'm going to be able to do is to write out the instruction, the operand, and a comment. And I also want these to be highlighted as well, as you could see. And what this will allow me to do is to write the assembly program just in the text editor. And then by pressing the play button, that would be here, the PC will connect via UART to an Arduino, and this program will be converted into just binary data. So what that will happen, and to convert it to binary, what you basically have to do is convert this operand from text to 4 bits of data, and then this will be appended to the front of this. So you will just have 8 bits, and that will be 8 bits for however long the program is. And what the Arduino will do is that will connect to the ROM, which I will probably use RAM chips in place of ROM, just because I don't have any ROMs to use. So how it would work is that the CPU has its own RAM, and then there will be another RAM chip which will act as a ROM chip for the CPU, so the CPU will only be able to read from the ROM chip, but it's really a RAM chip, and the Arduino knows that, and the Arduino can write the program to that RAM chip. And how that would work is that each of these lines is converted into 8 bits, and then each line symbolizes a different address. So this is address 0, address 1, 2, and then the Arduino will go through the addresses inside of the RAM, which is really a ROM as far as the CPU knows, and it's just going to write all of this data. So effectively what we've done is we've made a compiler, or in proper terms it would be an assembler, and that can program the custom architecture. Alright, so last time we went over the different assembly instructions. I made an emulator for them. So let's just try to demonstrate why I chose those instructions, and why you could do anything you could do with a normal computer with them. So if you've ever written C or Java or anything, you're familiar with a for loop. Basically what it does is for x equals 0, x less than 5, x plus plus. What this effectively will do is it will loop here 5 times. And as far as lines of code, it's really only 2. There's this, and that's just a bracket. Most of the code runs up here. So we don't have C in my custom architecture, we can't program in C. We have to use assembly and my custom assembly language right here. Albeit it is much more verbose than the C code would be, or even most assembly code would be. It should be able to accomplish a for loop using several instructions. So the first thing we're going to do is we're going to load 0 into the accumulator. Recall that load loads a number into the accumulator. All other opcodes load a value pointed in an address. So for these, if this command is load, this would be a value. For all the rest of these, this is an address. And what it's going to do is it's going to load 0 into the accumulator. And then we're going to move the value in the accumulator to address 2. So X is going to be 0 and it is going to be stored in address 2 effectively. For assembly, we don't have proper variables, we have memory addresses. And each of those could store values. So that's what we are going to use. And now we are going to load in 5. So now the accumulator equals 5. And now we are going to subtract from, now we are going to subtract address 2 from the accumulator. So now the accumulator equals 5 minus X. And now we are going to get this 5 minus X, and now that is inside of the accumulator. So now we can move that to address 3. And it's going to be there. This is just to store it because we don't have multiple registers, and we are going to have to use the accumulator again because we have to increment X. And how we're going to do that is we're going to load 1 in the accumulator, and now we're going to add address 2, which is X. So now the accumulator equals the accumulator plus X, or the accumulator equals 1 plus X, or X plus plus this. And yeah, so we have that, and then this is going to increment X. Okay, so now we're going to load in 0, and that just kind of clears it. And now we're going to add what's in the accumulator, which is 0, to address 3. So what's in address 3? 5 minus X. So we're going to load that to the accumulator. And then we're going to branch if not 0. So to 4, which is here. So this is the loop. From here to here and back again if this condition is met. Branch if not 0. What does that mean? If 5 minus X is not 0, so 5 minus X, which is here, and it's in the accumulator now. If this is not 0, then we're going to loop. So that means as soon as X equals 5, the loop is going to break. So effectively what this is a for loop, and that's just a demonstration of how these instructions could be implemented. Though I must note that the computer system which we're making is a 4-bit system, and what that means is, well, you have 4 bits of data, 4 addresses. So that means that you might have an issue where as soon as you get 16 of these lines, it'll be too much, or you could go farther, I think, but your loops can only be 16 lines long, which could be a problem, especially since like this for loop pretty much takes up that many lines already. So in any case, this is a basic overview of my computer architecture, and I hope you enjoyed this video, and I will see you in the next update for this project.